This is the pricing as per US East 1 region. As I said, you'll have to pay 50 cents per hosted zone per month for the first 25 hosted zones. Additional hosted zones will be charged at 10 cents per hosted zone per month. For example, suppose you have 100 hosted zones for 100 different domain names. The first 25 hosted zones would be charged at 50 cents, so it will cost you $12.5. And the next 75 hosted zones would be charged at 10 cents per hosted zone, which will cost you $7.5. So totally you'll have to pay $20 per month for all the 100 hosted zones which you have created. Not only that, Route 53 also charges you for the routing policies which you create. Like standard queries are charged at 40 cents per million queries for the first billion queries per month and 20 cents thereafter. For latency based queries, it's 60 cents per million queries for the first billion queries per month and 30 cents per million queries thereafter. Similar is the case with GeoDNS queries. Health checks are also charged. If the health checks are monitoring AWS endpoints, then you'll have to pay 50 cents per health check per month. If the health checks are monitoring any non-AWS endpoints, then you'll have to pay 75 cents per health check per month. So Route 53 is not free in any way. If you talk about SLA, AWS provides a documented 100% SLA for Route 53. Let's see some design patterns. Route 53 can be useful in various scenarios of architectural design patterns. For example, if you want to migrate your application from on-premise infrastructure to AWS without any downtime, or set up DR scenario, Route 53 can be exploited to achieve exactly the same. Something like this can be used. On your right hand side, you have your applications migrated from on-premise environment, but it is not live to customers yet. What you can do is create a Route 53 hosted zone with weighted round robin record set. Applications on your corporate data center is set up to receive 100% of traffic. Although you have record set pointing towards AWS, it is not receiving any traffic as of now. Once you test your entire application and make sure everything is working fine, slowly you can swap your traffic other way around. This should be done slowly, as I said. That means you should start to divert 10% of your traffic to AWS, then 20%, then 50%, and finally 100%. There is one more design pattern which is very famous in today's agile development method and in the era of continuous integration and continuous deployment, which is called blue-green deployment. The underlying concept is similar to which you have just seen. As you see, you have blue environment and green environment. Blue environment is live. Green environment is the exact replica of your blue environment. So you do all your testing in the green environment, and once you see or feel or test that your green environment is perfectly fine, you just swap it over and make the green environment as the live one. Exactly similar like we have just seen in the previous slide. As I just said, blue-green deployments provide near zero downtime release and rollback capabilities. The fundamental idea behind blue-green deployment is to shift traffic between two identical environments that are running different versions of the application. The blue environment represents the current application version, serving production traffic. In parallel, the green environment is running a different version of the application, which is a modified version actually. After the green environment is ready and tested, production traffic is redirected from blue to green. If any problems are identified, rollback can be done very easily by reverting traffic back to the blue environment. The same thing could have been done using autoscaling as well. Blue-green deployment using autoscaling. To implement this technique, we can start with an autoscaling group and elastic load balancer. The current launch configuration has the blue environment. To deploy a new version of the application in the green environment, autoscaling group needs to be updated with the new launch configuration. And then scale the autoscaling group to twice its original size. Then shrink the autoscaling group back to the original size. By default, instances with the old launch configuration are removed first. To perform a rollback, we'll have to update autoscaling group with the launch configuration again. Then the same steps can be performed in reverse. That's all I want to talk about the different design patterns using Route 53. Thanks for watching.